Pre-statistics. Determining appropriate viewing window when we graph linear functions. Part 2. Lesson objective. Determine the appropriate viewing window on the TI-8384 when graphing a linear function. We'll begin with an example. f of x equals 1 over 1,000 x minus 5. This is in function notation, and we see that this is a linear function because it's in the form y equals mx plus b. The slope is 1 over 1,000, so the rise is 1, the run is 1,000. So this is a very flat slope, and we can see that the value of b is negative 5, so that's our y-intercept. To graph this, we'll go to our graphing calculator. Here we are. We go to the y equals button, and then we type in our slope, 1 divided by 1,000. That's times x, and this is our x key, minus 5. And we hit graph, and I'm using the standard window setting, and this almost looks like a horizontal line. Again, that's because our slope is very small. To get a better picture of what's going on with this function, it would be a good idea to determine the x-intercept and adjust the window settings to allow for that. So back to our function, we know that the y-intercept is negative 5, and if you recall, one way of doing that is we can let x be 0 and we solve for y, and we see that the y-intercept of course is 5. For the x-intercept, we let y be 0 and we solve for x. So we have the equation 0 equals 1 over 1,000 times x minus 5. We're solving for x, so we need to get rid of this number and this number. Following the order of operation backwards, we're going to get rid of subtraction before we get rid of multiplication. So the inverse operation of subtract 5 is to add 5. So if we add 5 to both sides, we have 5 equals 1 over 1,000 times x. Now the inverse of multiplying by 1 over 1,000 is to divide by 1 over 1,000. And if I divide by 1 over 1,000, that's the same thing as multiplying by 1,000. And it turns out that our x-intercept is 5,000. When x is 5,000, the value of y is 0. Let's use that information to adjust our viewing window. So I'll go to the window key. The x-intercept is 5,000. So I want the x-min to be smaller. I want the x-max to be a little bit larger. To see the y-intercept, I'm going to let x-min not be 0 because I won't be able to see the axis, but negative 500. Now why am I choosing negative 500? Because the x-intercept's 5,000. My x-scale is going to be a large number. I'm going to use 500. Therefore, to see the y-axis, I need to be to the left of 0 by 500. So for the x-max, our x-intercept's 5,000. I'm going to go 2 tick marks beyond that. I'm going to let x-max be 6,000. And again, my x-scale is going to be 500. Because this distance is 6,500, I'm counting by 500. I'll be able to see the tick marks clearly. Now for the min, it's at negative 10. My y-intercept was negative 5. So I'm going to leave this at negative 10. Again, you can always graph it and adjust it later on. So I'm just going to take a ballpark guess. As far as my max, I don't think I need it to go to 10. Since the intercept's at negative 5, I'm just going to let the x max be 5. And since this distance is 15, I'm going to leave the x scale as 1. So let's see what this looks like. So I hit graph. And here we can see the y-intercept of negative 5. And here we can see the x-intercept of around 5,000. So this is 500, this is 1,000, 1,500, 2,000, so on and so forth. So now when I hit the trace key, I still can see the full graph, but I can also see these values. And as I move along and look at the order pairs, we can see that this slope is a positive slope, but actually it's increasing very, very slowly. Actually, it takes x to be 5,000 when y is 0. So it's increasing very slowly. Now, instead of finding the x and y intercepts by using algebra, we can also use the table feature, and that will help us to identify what the x and y intercept are. And let's try that. If I hit second and graph, which is table, here I see when x is 0, y is -5. And if I look at these values as x increases by 1, these values are getting larger, but they're increasing at a very small rate. I can change this to where instead of counting by 1, I can count by tens or hundreds or even 1,000. I think I'm going to try 500. So if I hit second and window, which is table set, I can start at 0. I can change that if I like. So this means change in the table. The default is 1, count by 1s. Let's change it to 500. So we're going to count by 500. So if I hit second and graph again, which is table, here I get a better idea of what's going on. And here is the y-intercept. To find the x-intercept, we keep scrolling down until we see where y is 0, and that's my x-intercept. So we have two ways of identifying the x and y intercepts. We can do it algebraically, or we can do it numerically by using the table feature. Let's try another example. Here we have a standard form of a linear equation. 0.2x minus 0.3y equals 15. Before we start, it's probably a good idea. I'm going to do this algebraically to determine what's the x and y intercepts. For the y-intercept, I let x be 0 and I solve for y. So this becomes 0.2 times 0, which is 0, minus 0.3y equals 15. That's our equation. Now I need to divide by -0.3, and I get y is equal to a -50. So my y-intercept's -50. For the x-intercept, I let y be 0 and I solve for x. So this gives me the equation 0.2x equals 15. Divide by 0.2, the x-intercept is 75. Now before I can put this into the TI calculator, I first have to write this standard form into y equals mx plus b form. So that means I need to solve for y. So we have to do that next. So to solve for y, I need to get rid of this -0.3, and I need to get rid of the 0.2x. Since this is multiplying and this is adding, I'm going to get rid of this first. So I subtract 0.2x to both sides. These are not like terms, so I get -0.2x plus 15, and then I divide by -0.3 to both sides. These cancel, and I'm left with y equals. Now the -0.3 is dividing both terms over here, so negative over negative, they cancel. 0.2 divided by 0.3, that's the same thing as 2/3. And a positive 15 divided by a -0.3, positive divided by negative is negative. So the equation becomes y equals 2/3 x minus 50. Again, this is our y-intercept minus 50. Our slope is positive 2/3. The rise is 2, the run is a positive 3. So let's graph this. So first, I'm going to go to the y equals. I'm going to hit the clear key. I'm going to type in my function. The slope is 2/3, 2 divided by 3. Next is x minus 50. I'm going to hit zoom and number 6, zoom standard, and we have our standard viewing window. Now if I hit graph, again it doesn't look like it graphed anything, but it did. We just can't see it in this window setting. So to change it, I go to window. The x-intercept is 75, so in order to see the y-axis, I'm going to leave this -10, but I want the x max to be something larger than 75, and I'm going to try 85. Now this span is about 95. My scale for my x, I'm going to let that be 10. The y-intercept was -50. -10, I won't be able to see it, so I need something less than -50. I'm going to try -70. And again, you can try this, graph it, and if you don't like it, you can go back and change it. As far as my max, I want this to be a positive number so I can see the x-axis, and 10 looks good. This distance between these two values is 80, instead of counting by ones, I'm going to count by 10. Now we hit graph, and we have our equation. I can see my y-intercept, I can see my x-intercept. If I need to use the trace key, I can. And if I hit second trace, which is calculate, there's a nice command called value, and that's number 1. So if I hit that, hit enter, I get this screen, and if I type in a value, x equals, it will find the corresponding y value. So for example, if I wanted to know what is the y value when x is 10, I type in a 10, hit enter, and it tells me y is a negative 43.3 repeating. If I want to know if x is 45, the input of 45 gives me an output of negative 20. Thanks for watching.